We want to solve sine negative 3x equals square root 2 over 2 on the interval from 0 to 2 pi. The first thing you always want to do when you're solving these equations, if you have a negative argument or angle, is to apply even odd properties and get rid of that negative. So let's do that. We know that the sine of negative theta is negative sine theta, so I'm going to make this a positive and put the negative right here. And then I'm going to multiply both sides by a -1 to get rid of it off from the trig function side. So it gives me sine of 3x equal negative square root 2 over 2. Now I'm ready to go ahead and solve this. Alright, so I'm first thinking about where the sine is negative square root 2 over 2, and so I'm kind of thinking about this like a theta for a minute. So it's negative square root 2 over 2. Well, that's going to be at multiples of pi fourth in quadrants 3 and 4. So it looks like it's going to be at 5 pi fourths plus 2 pi k to get all solutions from that. The second one would be 7 pi fourths plus 2 pi k. Now we didn't have theta, we had 3x. So I'm going to change that and substitute 3x in for the theta. 5 pi fourths plus 2 pi k. I'm going to divide everything by 3 to solve for x, and this would give me all solutions for that first angle and loops around. So 5 pi twelfths plus 2 pi thirds k. Now we only need enough loops to get all the answers between 0 and 2 pi here, because this didn't say all solutions, it said between 0 and 2 pi. Because it's a 3 in front of the x, normally I would have gotten 2 solutions on one loop. I now need 6. So I know I'm headed towards 6 solutions. Let's go ahead and finish the second one. 3x equals 7 pi fourths plus 2 pi k, and we're going to divide everything by 3, and so that makes us 7 pi twelfths plus, and rather than write 2 pi thirds, let's go ahead and make it into twelfths. So we'll multiply by 4. That was 8 pi twelfths k. And this one we'll think of it as 8 pi twelfths k, so we can add things on. Alright, we're ready to write our solutions now, and between 0 and 2 pi there's going to be 6 of those. The first of them will come from this first answer when the k is 0. So the first one is going to be 5 pi twelfths. The second one would come from this one, 7 pi twelfths. That was when the k was 0 on that. Now back to this first solution. We're going to look at it when the k is 1. So we're going to take the 5 pi twelfths and add 8 pi twelfths. So that's going to be 13 pi twelfths. And then down to the second one, we're going to add the 7 pi twelfths and 8 pi twelfths. So that's 15 pi twelfths. And I'm going to write this up here, just random place, because I knew it reduced, so I can think about it. 3 will go into 15 5 times, and 3 will go into 12 4 times, so 5 pi fourths. Okay, there are 4 solutions. I need 6, so I'm going back to my first one here and letting the k be 2. So I'm adding 16 pi twelfths to 5 pi twelfths, and that's going to be 21 pi twelfths. Actually, that one will reduce too. So 21 pi twelfths, we'll write it up here. 21 pi twelfths will reduce by 3s. That's going to reduce 7 pi fourths. 1, 2, 3, 4, 5. I need one more. So I'm going to take the second solution of 7 pi twelfths and add the 16 pi twelfths. So that's going to be 23 pi twelfths. If I added another loop around on the first solution, I'm going to be past my interval of 0 to 2 pi. Here are my 6 solutions to this equation.